The next few sample problems allow us to examine qualitatively the different ways that we can shift equilibrium. Right? And we talked about for Le Chatelier's principle, we can disturb equilibrium by changing the concentrations of species, the temperature, or the pressure. And pressure and volume, again, are kind of inversely related, whereas if we increase the volume, we decrease the pressure. Increase the pressure, we're going to decrease the volume. So these two kind of come together. So the next few sample problems are going to walk us through qualitatively how to think about a change in the direction of an equilibrium based on changing these variables. So here's our reaction here. We've got 2H2S reacting with O2 to give us 2S and 2H2O. And so what we want to think about here is what happens as we shift, as we change concentrations of some species. So again, what happens to the H2O concentration if we add O2? So one of the things that we'll actually have to think about here first is look at the direction that we're going to shift, and after we think about how the direction shifts, we'll think about how that affects the concentration of this species. So if we add O2, remember adding a reagent is a push, so if we push on the equilibrium here, we're going to shift it to the right. So we're going to shift to the right. If we shift to the right, we're going to increase the concentration of anything that's a product. H2O is a product, so in this case, we're going to increase the concentration of H2O. Again, adding O2, we're going to shift to the right. H2S is a reactant, which means its concentration will decrease as we shift to the right. O2 concentrations here. So if we think about removing H2S, anytime we remove something, think about that as a pull. So removing this, we're going to pull on this, the equilibrium is going to shift to the left. So this time, shifting to the left will increase the concentration of a reactant, so we're going to increase the concentration of O2. And again, if sulfur is added, if we look here and we see that sulfur is a solid, sulfur is not part of our equilibrium expression because it's a solid. So in this case, there's going to be no change in the concentration of H2S as we add or remove sulfur. So pretty straightforward with these problems. There's lots of ways that we could ask this problem. I could ask which way will the reaction shift. I can ask specifically for concentrations of species and ask if they will increase or decrease, or I could ask concentrations of which species will increase. So lots of different permutations in terms of how this question can be asked, but all fundamentally boiling down to the same thing. Look at reagents being added or removed. Things that are added, think about it as a push. Remove, think about it as a pull, and use that to determine which direction the equilibrium will shift.